Do we know all of our formulas? So what are our arithmetic formulas? A sub n equals A1 plus D times n minus 1. What's the main S sub n? N times A1, AN over 2. What's the hybrid S sub n? 2A1s. And then just the, yeah. Okay. And now we got our geos. AN equals A1 times R to the n minus 1. What's the main S sub n? A1 times the quantity of 1 minus R to the n over 1 minus R. What's the hybrid? Hybrid is A sub 1 minus R A sub n's, 1 minus R. And then yesterday we did the new one of just S, which is the infinite one, A1 over 1 minus R. And when is the only time you can, so that's for infinite, but you can't use this for all infinite series. Only geometric where R is what? Less than 1, right? So it has to be exponential decay. It's not going to work if it's exponential growth.
So not less than 1, you just solve it.
Yes. So if you have something like this, okay. These two problems. One of these is solvable. One of these is not. Which one's which? This one's solvable. Why? Because the R value here is 1/4. It's less than 1. So I can solve this. And all I have to do is find A sub 1, which plug in a 1. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 4 would be 4. What's my R? So I go, what goes here? So it's 1 minus R, right? So that'd be 3/4. So I got to do 4 divided by 3/4, which is the same as 4, I gotta move down, times the reciprocal, or 16/3 would be the answer. So that has an answer. It's like 5 1/3 or something. Okay, can I solve this one? This one is what we call divergent, because the R is 2, 2 is bigger than 1, this is just going to go to infinity. There is no answer to that, right? Make sense? Because remember, before yesterday, if I were to ask you, what's the definition of convergent? What does converge mean? To convert. If I were to say, everybody converge over here. Yeah, flagpole. It would mean everybody's going, it's going to mean you're all going to slowly come together, right? Well, that's exactly what that means, is this answer is converging. It's going to get closer and closer and closer and closer and closer, infinitely close to that 16/3. Yes? All right, everybody take a look at page 400. 400. Let's go through some of these real quick. The biggest thing with infinite series that you have to know is, are they solvable or not? Because if they're solvable, it's really easy to find. But it's also, people make the mistake of thinking a problem like this, I can solve with the easy formula and say, oh, my a sub 1 would just be 4 over 1 minus 2, which is negative 4. That's not going to be anywhere close to negative 4, is it? Like if I found the first term would be 4, and then the next term would be 8, and then the next term would be 16, I don't get anywhere near negative 4 as an answer. So no, this is not even close to the right answer. So the formula doesn't always work for infinite series. It only works for convergent ones. So for example, number 1. Is that one solvable? It says 1, 1/7, 1/49. You got to figure out your R value. What's the R value there? 1/7. Is that one going to be solvable? Then yes. So I can solve that by just saying, what's my a sub 1? 1. 1 minus a seventh, which would be 1 divided by 6/7, or 7/6. The answer to that question? 7/6. Is number 2 solvable? Yeah, because you're multiplying by 2/7. 2/7 is less than 1. What's the first one that's not solvable? 3 is solvable. 5, right? Because my R value would be 1. If you add up an infinite number of 2's, that's basically 2 times infinity. It's going to be a large number. Now, a hard one is number 6. Is that what you're going to ask about? It doesn't, though, because if you add up 2 minus 2 plus 2 minus 2 plus 2 minus 2, right? But it's not. It's not forever going to be 0, because it depends on, is infinite an odd number or an even number? It's neither, right? Because if I add up an even number of terms, yeah, the answer is 0. But if I add up an odd number of terms, so if I keep adding these up, it goes, like graphically, it goes 0, 2, 0, 2, 0, 2, 0, 2. Is that pattern going to converge onto a single number, or is it going to keep jumping back and forth? It's going to keep jumping back and forth. So this has no answer. This has no solution, doesn't exist. Like it's not solvable because your R value is negative 1, right? Which is not in that range. So, make sense? So that one's a little tricky because you kind of want to say the answer should be 0. But you could argue the answer is 0 and kind of be correct. And he could say the answer is 2 and be equally correct because you're both correct half the time. So, does that make sense about the converging thing now? I think that example demonstrates the converging idea pretty well. So, are we good with those? The other ones I want to make sure you're good at are the repeating decimal ones. Like number 13. How do you take this number and turn it into a fraction? Think of it as the geometric sequence. 4 plus 0.04 plus 0.004, and so on and so on. So my a sub 1 is 0.4. What's my R value? How many times am I moving the decimal from one term to the next? 0.1. Basically, when you do these, if there is one digit repeating, your R value will always be 0.1. If there are 2 digits repeating, your R value will always be 0.01. If there are 3 digits repeating, it's always going to be 0.001, and so on and so on. Like, it just depends on how many digits are repeating. Now you just solve it. 1 minus 0.1 is 0.9. I don't want the decimal there, so I want to move it twice, or move it once on top and bottom. So 4/9 is the answer. There will be a quiz question like that. Super easy though, right? And then if I give you 0.15 and they're both repeating, then that'd be my a sub 1 is 0.15. What's your r value? There's 2 digits repeating, so it should be 0.01. And think of that like $1 minus a penny, so that'd be 99 cents. And then I don't want the decimal, so I got to move it twice, so 15 over 99, which, yes, would reduce because you can divide by 3. And there's your best answer. Easy? How can you check that you have the right answer? Type in 5 divided by 33 and see if it gives you 0.15. If I give you one that has a part that's not repeating, like let's say it's 0.15, but only the 5 is repeating. Well, think of it as take the 0.1 away. Your a sub 1 would then be 0.05. That's the first number that's repeating. 0.005 and so on and so on. So your a sub 1 is just that. How many digits are repeating? Just 1. So what's your r value? 0.1. So it's 0.05 divided by 0.9. I want to move the decimal twice. So 5, move it twice, 90, which does reduce to 1. What's 90 divided by 5? 18? 1/18? Now, if you type in 1/18 in your calculator, it will say 0.055555. But I want to put that 1/10 back in there. So to put the 1/10 back in there, just add the 1/10. Which, yes, you need a common denominator, so put it back to 90. 5/90ths plus 9/90ths would be 14/90ths, which does reduce to, what, 7 over 45? Does that make sense? Are we good with those? Check it with your calculator. Please don't get those wrong. Those are easy ones. Are we good with those? Anything on geometric infinite series? Okay. The other section that will be on your quiz is the non-infinite ones. So the ones we did just the other day that deal with, so basically your entire quiz tomorrow will be on the right side of that line. It's just these formulas. Everything's going to be geometric. Except I do reserve the right to put a little bit of that one on the quiz. Because you may very easily get question number 1 look like this. And question number 2 look like this. Why would I put those on the quiz? No. Because what's the first thing you got to figure out? Is it arithmetic or geometric? Which one's which? This is arithmetic because that's linear, right? So I got to use an arithmetic formula, which is the number of terms, which is 8. Find a sub 1, so you plug in a 1 and you get what? 1? Find a sub 8, so you plug in an 8. 4 times 8 is 32. 32 minus 3 would be 29. Divide that by 2, calculate. And then this one's geometric, right? So now that I know it's geometric, I got to use a geometric, which is find a sub 1. 3 to the 1 is 3. 3 times 4 is 12. 1 minus my r to the nth power over 1 minus r. Good? That's pretty much the whole quiz. So the whole quiz is going to be all geometric. 90%, 98% of the quiz is going to be geometric. There might be one or two of these on there just to test whether or not you recognize which one's arithmetic, which one's geometric. Okay? Are we good?